question 16, I've started just by drawing the big outside of triangle here. And you're told that from one end to the other is 12, and you've got an angle there of 1.2. So if I wanted to find out this opposite side over here, I could do the tan of the angle equals the opposite divided by the adjacent side. And so this side here is 12 times the tan of 1.2. And if I do the cos of it as well, the cos of 1.2 is adjacent over the hypotenuse. And so rearranging that, I can see that this whole side here is 12 divided by the cos of 1.2. That's the distance from there all the way up to there, which we might need later. Now, the other thing you've been given is that actually we've got a little sector coming across here. And that means that that distance there to there is 12. I know my diagram's getting a little bit annoying now. And you're bringing a line straight down there. So I wonder how much it is from here to here. So just looking at the small triangle for that part, and the small triangle for that part has got 12 from there to there, and this being 1.2. And if I want that value there, it's the adjacent angle. So that point there is 12, the cos of 1.2. I mean, I've done them all at the beginning because now I can figure out the questions. So the area of this section here, so the area of that section there is the area of the triangle. And the area of the triangle is a half times the base times that height, which is 12 tan 1.2. Take away the area of the sector, as we've been doing before, a half r squared theta. So if you take those away from each other, that gives you, I think I've got 98.79 there. I'll just check that. Yeah, 98.7949. So that one's okay. Now we're being asked to find out what the perimeter of DAB is. So D to A to B. So the perimeter of this part here. So this part here along the bottom is the difference between the 12 and the 12 cos 1.2. The curved part is your normal arc length, so that's just r times by theta. That's that part there. And this part here, well, actually that's that part there of that triangle there, isn't it? So that's the sine of that. So 12 sine of 1.2. So now tapping these into the calculator, this one here I've got 7.65. 12 times 1.2 is, we should know that one, 14.4. That's that part there. And this one here, 12, the sine of 1.2 is 11.18. Add each of those bits together, I'm getting 33.24 centimeters. So lots there, and I think go back and look at the big triangle and think about the sides there with this being 12 and the small triangle with this being 12, and working them all out with trig if you need more.